Well, with the improvement of people's living standards, people's investment methods are also undergoing tremendous changes. More and more people are paying attention to and participating in stock market investments. Stocks have both high returns and high risks. The stock market is influenced by multiple factors and prices are unpredictable. Therefore, research on stock price prediction has great value. In this topic, I'm going to introduce something related to machine learning as well as support vector machines known as SVM model. I will use it to predict the stock prices. The rough sketch is that I will read dataset from internet and do some pre-processing on it, and then I will perform feature filtering and analyze data to establish some SVM models. Finally, I will evaluate the reliability of the model, including drawing ROC charts, calculating loss values, and comparing the predicting stock prices with real stock prices. So first, the data are selected from website and from some stock apps, which are formal databases to get multiple stock data. Also, we can get data from some third-party libraries in Python like toShare. Due to the chaotic and disorderly nature of stock data, it is not suitable to select too much data as the dataset for model training. I selected 500 training days from the obtained data at the training set. Among them, due to the lack of target features in the dataset, we can only calculate and features ourselves. Here, date represent date. Opening price of the day. High is the highest price of the day, and the low is the lowest price of the day. And volume is the number of shares traded on the day. Amount is the trading volume of the day. I also added a diff here. I also added diff and up. Diff is the price change of the day, and up is the target value that indicates whether the price increases today. And we can see one indicates increasing and 0 indicates decreasing. Since data is not a variable that we need but only represents the order, I exclude date and show the table again. Oh, by the way, we need to find whether missing value exists in the dataset. Here we can see the missing value is none in the list. Next, I will use PCA, which means Principal Component Analysis, to select mean variables. PCA can convert high-dimensional data into one-dimensional data, allowing people to more intuitively select the mean feature data they need. We calculated the variance and contribution from the first three variables, opening price, closing price, and lowest price, have provided a contribution of 0.99997 from the values and images. They can represent the significant characteristics of the data. After assigning the data of the characteristic variable to the variable nx, normalizing the data of the characteristic variable and assigning the up data representing the fluctuation situation to the variable y, we begin to construct the SVM model. I import SVM model in sklearn library in Python as third-party library and construct SVM models using linear kernel function, polynomial function, sigmoid function, and RBF function, respectively. The purpose is to analyze the impact of different kernel functions on the stock prediction of the SVM model. After comparing the ROC curves, I found that different models have different ROC curve inflection points. Obviously, neither one had the highest inflection point, and it is significantly better at processing data than the other three kernel functions. Due to time limit, I will pass the confusion matrix, thermodynamic diagram, and model parameter scores. Overall, linear kernel functions perform best. To explain the results, linear kernel functions perform better in data processing and training. The error between its predicted trend curve and the actual curve is equivalent to the smallest of the other three kernel functions. We can see from the picture, this is the true and predicted values of a linear SVM. This is the actually price trend. And next one, this is the true and predicted values of SSVM. And this is PSVM, and this is RSVM. Overall, the SVM algorithm had a strong reliability and small error in predicting results, but it also consumes a certain amount of the time and reduces computational speed. Just like I only selected 500 data at the test set, but it took me almost 5 minutes to obtain the ROC curve and stock forecast trend. From the perspective of model evaluation, the kernel function of SVM algorithm is crucial for model scoring and accuracy, and different datasets are suitable for different kernel functions. However, some evaluation criteria cannot represent the quality of the model. For example, although the SVM model was always linear kernel function is the best, there is still a certain gap in the overlap between its true and predicted values, and it seems that there is a prediction time difference. We can see from the picture again. It seems that the predicted values should be delayed 2 days, and 2 days after it will be similar to the true values. And that's all for my presentation.